The exponential smoothing method that we learned is not suitable for forecasting if there is a trend in your data. So what should we do then? Well, you can actually adjust and customize your model, the exponential smoothing model, um, to able to be able to use it to make a forecast when you have trends. And the method is called, the adjusted method is called trend adjusted exponential smoothing. The trend adjusted exponential smoothing forecasting method, it has two components. It has the smoothing component and the trend component. As you can see from the formula of the trend adjusted exponential smoothing, TAF for t plus 1. TAF is the trend adjusted forecast for the next period t plus 1. We are in period t. So that's equal to the smoothing component for period t, which is the previous forecast that you have made plus the smoothed error. T, the capital T of the current period, is the current trend estimates in your data. We are not going to go too much detail about the trend adjusted exponential smoothing. I just wanted to give you this understanding that you should not use the exponential smoothing method if you have a trend in your data. Instead, you can use the trend adjusted exponential smoothing. I'm going to show you the formula later, but again, we're not going to go in more detail into this formula. The trend adjusted exponential smoothing formula has the two components, the smoothing component and the trend component. The smoothing component is equal to your previous forecast plus the smoothing error. So as you can see in this formula right here, the smoothing component S of t, t stands for the period that we are in right now. That's period t. The previous period would be t minus 1, and the next period would be t plus 1. So S of t is equal to the TAF for the TAF for t. That means that the forecast that you made using this formula when you were in t minus 1 for t, plus the smoothing constant alpha that you are familiar with from the exponential smoothing formula multiplied by the error. So the error is the actual value for t minus the forecast for t. The trend factor, T of t, is equal to the trend value from the previous period plus the smoothing constant beta multiplied by TAF for the current period minus TAF from the previous period minus T from the previous period. Because of inclusion of the trend component, the trend adjusted component, this makes our trend adjusted exponential smoothing forecasting formula to be able to respond to changes in trend. And also, if you look at the formula that we have here, it's a recursive formula. So S of t, for example, it's always go back to the previous formula. So TAF, we are computing TAF for t plus 1, and in the S component, we have TAF. That means the TAF from the previous period. Or we are computing T of t, and we are using the T of t minus 1 in that. So this is called a recursive formula. That means that each time that you are computing something from the next period, you're using something from the previous period. So how far can you go back? I mean, you need to have a starting point. That's why for this formula, the trend adjusted exponential smoothing, you need to have two initial data points. First is the initial estimation of trend using the data of the first 4 periods, for example, and also the initial forecast. For that, you can, for example, use the naive method to make an initial forecast. And then you get the formula going with these initial points. So we're not going to have an example of this. This is just a demonstration of the necessity to adjust the trend the necessity of adjusting the exponential smoothing method to the trend. If you have trend in your data, you should not use the basic and simple exponential smoothing method.